All right, now we can actually delve into looking at the naming of the coordination compounds. And here's a chart that shows the basic rule that we're going to follow is if it is a counterion, if it is a free, for example, chloride, it's named as chloride with an IDE ending. If it is attached to the metal center, it is chloro. And as we saw in the previous presentation, there are times where we have some chlorides hanging out as counterions, and we have chloros that are attached to the metal center. Cyanide becomes cyano. The most common ones are ammonia, NH3, becomes amine. It gets this double M to distinguish it from any other amine that we could be talking about, AMMINE. Carbon monoxide, when it's a ligand, is carbonyl. And then finally, water, when it's a ligand, is aqua. So water attached to a metal center is an aqua ligand. Basic protocol here is going to be that we name the ligands attached to the metal as prefixes before the metal name. And some ligands, their common names and their systematic names for nomenclature are given above. So this part is just like in general chemistry. We name the cation and name the anion. But the deal here is that the cation is a complex cation. So we have to put in a little bit more work to name the cation. We name the ligands first. So there's 5 ammonias, pentaamine, and don't forget the double M, pentaamine. Chloro, because there's only one chloride attached to the cobalt. Then we name the metal. So pentaamine, chloro, cobalt. We need to say what the charge is on the metal. We have a chloride, and a chloride. So this must be, for the whole thing to be neutral, must be cobalt 3, which we name in Roman numerals. So the cation is a complex cation, pentaamine, chloro, cobalt 3, space, and then we name the anion. The anion is a simple anion, chloride. The ligands are listed alphabetically before the metal. This is the official way to do it. This, in reality, gets scrambled around all the time depending on what a person is talking about. And so I don't care too much that they're done alphabetically. You want to do the name correctly, but I don't, it's not super important that those are in order, but that's the way they should be. The names of anionic ligands end in O. The endings of neutral ligands are not changed. And so pentaamine, amine stays as amine when it's attached to the metal. Chloride becomes chloro. The prefixes bis, tris, etc. are used if we have more than one of a complex ligand. And so like ethylene diamine, if we had 2 ethylene diamines, it would be bis ethylene diamine. Or if we have 3 ethylene diamines, it would be tris ethylene diamine, because it would be confusing to be diethylene diamine or triethylene diamine. And so we switch these complex prefixes of bis and tris and so on if we have more than one of a complex ligand. All right, now we're going to look at a new complex. Here we have a simple cation, sodium, but we have a complex anion. And so the first part's easy, sodium, and then a space. Then we need to say what all the ligands are. So there are 4 chlorides, tetrachloro, and then there's an oxo ligand, tetrachlorooxo. And when it is part of a complex anion, the ending of the name changes. So it is not written as molybdenum, but it is written as molybdate. It gets an 8 ending because it is a part of a complex anion. Even though the metal itself has a positive charge, the complex is a complex anion. So so this indicates it's a 4 plus charge on the metal. Let's see if that makes sense. There's 4 chlorides, so that's 4 minus. An oxo is 2 minus. Okay, so that's 6 minus from the ligands. And then there's 2 plus out here from the sodiums. And so the molybdenum needs to be 4+ in order for the whole complex to be neutral. Okay, if the compound is a salt, name the cation first and the anion first, just like with simple salts. In naming a complex ion or a neutral complex, name the ligands first. The ligand names always go first. Anionic ligands get an O at the end, so cyanide becomes cyano, chloride becomes chloro. Neutral ligands are specified by their usual names, except for water becomes aqua, NH3 becomes amine, and CO becomes carbonyl. If the complex contains more than one ligand of a particular type, indicate the number with the appropriate Greek prefix, di, tri, and so on. The ligands are listed in alphabetical order, and the prefixes are ignored when we're determining that order. If the name of the ligand itself contains a prefix, then we need to use the fancy prefixes, such as bis, tris, tetrachus, and so forth. We use a Roman numeral in parentheses immediately following the name of the metal to indicate its oxidation state. In naming the metal, use the ending "ate" if the metal is an anionic complex. Some anion names are Latin. So some of them are simple. Aluminum becomes aluminate. Chromium becomes chromate. But for example, copper becomes cuprate. Gold becomes aurate. Iron becomes ferrate.